Okay, Newton's theory of gravity explained why the moon orbits around the Earth, and why the moons of other planets orbit around them, and why the planets orbit around the sun. But we knew from those the equations that if we were able to put something man-made into space and make it move fast enough, we could get it to orbit the Earth. And the Soviet Union was the first country to do this. They had a tiny little satellite called Sputnik. Um, they launched it in 1957, um, and it was the first object we were able to get that would orbit around planet Earth, and it just kind of put out a radio signal that people could pick up on their radio receivers, and you can read the information here. It spent 3 months in orbit, traveled about 60 million kilometers. That was the first satellite. Since then, we have launched lots and lots of satellites into space to do lots and lots of different things. And we'll work through these questions together. Just so it says, give 3 common uses of satellites. One of them is communication. So most mobile phones don't use satellites to make calls, they just use masts, but you can get phones that will send a signal up into a satellite in space and can get transmitted back down again. Likewise, if we're maybe recording, say, I don't know, an NFL football match in America and we want to get that signal over to the UK, we can send a signal up the satellite and back down again. If you get Sky TV, you'll have a satellite dish somewhere on your house that is pointing towards a satellite in space. So one of the things is communication. Another thing is spying. If we want to check where another country's tanks are, we can put a satellite up into space. Remember, space is only 100 kilometers away. So if you go directly up 100 kilometers, you get to the edge of our atmosphere. That's space. So they're not that far away. And with very powerful cameras, they can take very good photographs of the ground. Another one is the weather. So we can send satellites into space that can photograph and take readings of conditions all around Earth's atmosphere and the ground. And using that, then we can predict what we think the weather's going to be like in the future. Another one would be GPS satellites. So the GPS on your phone picks up signals from a number of satellites and does a little bit of maths, and using that, it can work out where you are in planet Earth to about the nearest meter. It then says what keeps a satellite in orbit. If you're asked what does anything in space, what causes something to happen, it's usually, and it is in this case, gravity that causes them to move in a circular motion. So it then says the satellite in low polar orbit is launched about 100 miles above Earth's surface. It takes about 80 to 90 minutes to complete one orbit of planet Earth. So if this is planet Earth, we can put a little satellite up here in a polar orbit that just orbits around planet Earth. Something like that. And the height of that is even exaggerated. Okay, Earth's atmosphere is very, very thin. The advantage of this is it's quite close to planet Earth, but Earth also spins underneath, which means that in about a 12-hour period, just looping up and down like that, it can photograph all of Earth's surface. So this is particularly useful for spy satellites and for weather satellites. However, the further a satellite gets away from planet Earth, so if we do one kind of a little bit further away, orbiting around the equator, this satellite has further to go, and it also needs to be slower because gravity is weaker where it is. So this might take about 90 minutes. Move this out here, might take about 2 hours. Okay. However, the further we go away, the bigger the path comes, and the slower it travels. So we can change the time it takes it to complete one orbit by moving it further and further away, and eventually we get to a particular distance where it takes it 24 hours to do one lap. Now the useful thing about that is Earth is also taking 24 hours to rotate underneath, which means if you're standing here, not the scale, on planet Earth, that satellite will always be directly above your head, because as you rotate round as Earth spins, so does it. And we call that geostationary or geosynchronous orbits, and they're very, very useful because let's say you do have satellite TV, you want to point your dish at a satellite, you don't want to have to constantly adjust that as it moves overhead. And in this case, this type of orbit, it stays fixed in the same position relative to planet Earth. This question, however, just asks us why one satellite takes much longer than the other to orbit the Earth. The polar satellite, in this case, has a shorter orbital path and a faster speed.